Hello everyone, welcome once again. So in the last session we talked about the DMAIC part review 1 where we talked about the defined phase toll gate review. We are in major phase now. In the major phase, idea is to collect the data and use the data to understand the pain of the customer, problem of the customer using that data. So the data that we are gathering can be classified into two types. One is the discrete data and another is continuous data. Discrete data is which is a count data, or you can also say data which is categorical data, while the continuous data is which you break into smaller pieces, still has a meaning. It has a measuring unit and a measuring scale. We prepare a data collection plan, the data that we are gathering. So which we are gathering is a sample has to be representative of the population, and it should be, to make it representative, we do a random stratified way of collecting the sample. Stratified is when we categorize the population into various parts, and from each of the parts we collect a random sample. So that becomes a random stratified, and it try to represent the population. And this data we put into a data collection plan format, wherein we have the operational definition, sample size, stratification factors, manual or automated collection type, what type of data is this, discrete or continuous. So that's information we have in the data collection plan. And then we try to do some statistical analysis on this data, and this statistical analysis can be we are looking at we're trying to understand the central tendency of this process for which we have collected data. Central tendency can be understood by either the mean or median of the process. When there is too much variation in the process, we do not look at mean as a process performance parameter, because process may not be balanced. But when process is balanced, then we look at mean as a center of the process. And to understand the variation in a process, we look at so range and standard deviation as a process performance parameter for the variation. When data set is small or there is hardly any variation, then maybe you can look at range as a process variation. But when process has variation, like a typical data set, then a uniform spread of the data, then you should look at standard deviation as a process performance parameter. Also for a large set of data, standard deviation is the right way of looking at process performance for variation. So this is about some numbers that we get, the central tendency and variation, but we also try to put that into a graphical format. We need to visualize the data. In order to visualize the data, we look at some of the tools like histogram that helps us to know what is the central tendency, what is the variation, what is the shape of the process. We look at the box plot that gives information about overall spread, gives us information like what is the median, what is the first quartile, what is the third quartile, what are the outliers in the process, what is the minimum and maximum data point. In one picture we can see all this information. Then we look at Pareto chart that talks about 80-20 principle. We try to prioritize, that's like what are the top 80% issues in the process where we should focus. And then you also look at another method called as the scatter plot that tells us the relationship between an independent variable x and a dependent variable y. So these are some of the ways we try to visualize the problems and the data for the same data that we had gathered. So that only helps us to understand and visualize the problem. But now what we try to do as part of this, the data that we have gathered, we also like to understand. We understand there is problem in the variation problem, or data may not be at center, we are not able to meet target, but are we able to meet customer requirement or not, we don't know yet. So that needs to be understood well, and for that we do capability study of the process, and we use a method called DPMO, defect per million opportunity. For that we use certain information like what is the definition of a defect, how many units are there, how many defects are there in each unit, how many opportunities are present for a defect, and then we calculate DPMO. And so higher the DPMO, lower is the sigma. So that's the information we receive from here. So that's an information we receive about the capability of the process. But we also try to detail out the entire process, understand the process in a much more detailed manner. For that we use a method called as process mapping. And similar to what we saw in defined phase, here we are looking at more process mapping methods. One very common process mapping method is activity chart, wherein we talk about the flow chart. Another way of mapping the process is called the swim lane diagram, where we have multiple swim lanes for each function, how process is going through each functions, what are bottleneck in the process, we understand that. And then we look at another very common type of process mapping method called as value stream map. That's where we understand what are the different value added, non-value added step in the process. And then we also look at 7 type of waste in a process, which summarized by Tim Wood, TIMWOOD: transportation, inventory, motion, waiting, overproduction, overprocessing, and defect. And at the end we have the measure phase toll gate review. Once we have identified a lot of these issues in the process, move to the analyze phase. As part of analyze phase, we do brainstorming to find the potential problems in a process. As many ideas we gather, in team sits gather a lot of potential ideas. Then at the end of the brainstorming session, we get a refined list, like these are the ideas we have, or problems that we can understand, or the potential causes for the problem. But we need to prioritize them using the control impact matrix, and we need to organize them into logical groups by a method called as fishbone diagram. You can also prioritize them using Pareto, also the top 80, but still will not give you which one has high priority. Like, so you do that through high control impact matrix, the prioritization that happens. So high control, high impact ones we look at that go for further root cause analysis. And for that we look at 5 why analysis. We ask why multiple times, and we call it why because analysis, wherein we look at potential cause, we ask why multiple times, and at the end of it we should have the root cause. So that's what we do in the analyze phase, and we can then prioritize if we have multiple root causes, again using control impact matrix. And at the end of the analyze phase, we again go through a toll gate review. And after the analyze phase is over, we should have the validated root causes in front of us, and we are good to go to generate the solutions to eliminate those root causes. So that's about the analyze phase. In the next session, we'll talk about the improve and the control phase. Thank you for watching. This is Shivendra Sharma.